Okay, welcome guys. So this video, let's prove solving this interesting probability question. Be sure to subscribe to my channel. I have a lot of probability question in my video list. Okay, so n people arrive separate to a dinner. Oh, okay. By the way, I like to use red. Upon arrival, each person looks to see if he or she has friends among those present. The person then sit either a table, so either a table or for friends, or sit an occupied table if none of those present is a friend. So basically, if you're a guy, right, you work in some restaurants, okay, right, there is a lot of table, and each table can contains infinite people, right, and there's people here, maybe some people here, and then you will see, if one of is your friend, and then you go to their table. If there's no friends, there's no friends in the restaurant, and then you go to final, right? You go to unoccupied table. Okay, and the question is very weird that each pair of people independently, you have a probability p, which you become a friend. Okay, so we want to ask the find expected number of unoccupied tables. Okay. So you at least know answer when p equals to 1, right? So when p equals to 1, then everyone should be a friend, right? So the expected number will be 1, right? Because everybody is a friend, so everybody can go into the first table. If the probability is 0, then you know that everyone cannot be the friend, right? So the expectation value should be n, right? Because n people, right? Total they go to different they total go to different table, right? Okay, so let's solve it. So the hint is use expectation value sum of the random variable. Okay, so that means that xi, right? Xi will be what? Will be i's people, right? So we have n's people, so i's people. Then what? We need to connect this random variable to the expected number table. So we should do this, right? The i's table will be 1, or 0. What kind of it will be 1, right? Means that the i's people goes to unoccupied table. Okay, and if i's people goes to occupied table, then I give it 1. I give it 0. Okay, so this is the random variable. Okay, so it's obviously that the number of expected occupied table, right, will be the sum of xi, right? So I from 1 to n exi, and then this is 1 or 0, so this will be just the probability of xi equals to 1, right? Because this ex1 is 1 times probability xi equals to 1 plus 0, right? Times. Okay, so this means that we just need to count what is the probability of xi equals to 1. Okay, now this is very easy, right? Because if the i's people go to unoccupied table, that means that he or she do not know any previously I minus 1 people cannot be he or she's friends, right? So the answer will be 1 minus p to the power I minus 1, right? This means that the i's people, I should say i's person, sorry, does not know any I minus 1 people. Okay, so this is the answer. Okay, it's interesting. Obviously, if p is 1, then right, you get 1, right? If p is 0, you get I think n. And it's very interesting that if you take n to be the infinity, then answer still be finite, right? For like maybe p to a half, right? Then answer will be like finite. So you will get 1 minus p plus 1 minus p squared, and the answer will be 1. Sorry, you compare to 0, 1, right? And the answer will be 1 divided by 1 minus p. So I mean, if n is infinity, the answer will be 1 over p, which is a little bit counterintuitive, right? So that means if you have infinite people, then the expected number of occupied tables should always be finite. Okay, which is very counterintuitive. Okay, but anyway, see you guys in the next video.